Welcome to another video. Today I want to talk about C++ Lambda functions. So this is from C++ 11 onwards. Yeah, these weren't originally included in C++, but they are in modern C++ compilers. So Lambda comes from the 1930s. A fellow called Alonzo Church described a new calculus for computing anything which is computable using little strings of nameless functions. And he called his calculus Lambda calculus. It's written with a little Greek letter lambda there like that. Yeah, so that's why they're called Lambda functions, but we'll go through what they are now. The syntax, well, the syntax is pretty interesting, really. It'll look a bit strange if you've not seen them before. So you'll often see it with auto and then some variable name and then square brackets and then some parameter list and then an optional little arrow symbol with the return type and the body of a function. So that's going to look pretty bizarre. That's going to look pretty bizarre, especially in the places where you actually see Lambda functions. I mean, they're defined in the middle of the bodies of other functions, but let's go through the parts. It'll all make sense, don't worry. Auto sum var. So what we're doing in a sense here is creating something like a variable pointer, to a function, not a variable pointer, sorry, a function pointer to a function with no name. That's kind of what we're doing. So auto sum var, the auto just here means, have the compiler make up whatever the data type is. And sum var is going to be our variable's name, the name of our function. The next is square brackets, which is called the Capsule List, and which we'll go through in just a second. After that, we have parameters. So in this instance, this particular Lambda function takes two parameters, an int a and a b. And after that, we've got just a weird little arrow thing, which is optional more often than not. And then a return value. So if you've got no return value, you can leave this little arrow and this int off. Likewise, if the return value is obvious to the compiler, like if you've only got one return statement in the body of your Lambda and it returns an int, then the compiler will just figure out that your Lambda returns int. And you can leave these two little bits off. Alright, so that's the basic syntax to a Lambda. Let's have a bit of a look at how they work. So if I just copy this over to our code, here we go. So I've got a bit of C++ happening. Don't worry about the headers up the top at the moment. We'll use all of those later. All right. So here is my little Lambda, an example of probably about the most simple Lambda you can get. Although I think this is probably the most simple Lambda you can get. No. There, yeah. That's the most simple Lambda you can get. Just a little parade of weird-looking brackets. Anyway, it doesn't do anything, so let's just move on. Okay, so the variable that I'm saving this Lambda to is going to be called say hello world, and the capture list is nothing. It takes no parameters, and the body of this particular Lambda just prints out no to the screen, as I'm sure computers are well sick of saying hello world. So all we'll see is no written to the screen, all things going to plan. My computer's probably freaking out a bit. I got it doing a million things at the moment, but yeah, there you go. So what's interesting here is that we've defined a function with no name, essentially. I mean, this Lambda function here has no name, and we've defined it in the middle of the body of our main function. This is what Lambdas are all about. Pretty weird, huh? Pretty weird. It's only going to get weirder. All right, my second example. This is a Lambda with parameters. Okay, so if we go back to our little hello world example here. If you want to pass some parameters, so say int a and int b or something like that, you can just pass them. And we could say maybe return a plus b. Something like that. And now our say hello world pointer just here points to a Lambda function that takes two parameters. So we better pass those. I might just pass 190 and 10 because that's nice and easy to add up. So we should get sorry, I'm typing. I can't do mental arithmetic. We'll get 200 will be the return of the Lambda here. The return of the Lambda. It sounds like a horror film. 200, there you go. As I was saying before, it's optional. The compiler can tell what the return type is, but for this particular Lambda, the return type is an int. So you could put that little arrow there and just explicitly state that the return type is an int. Yeah, but that's how you pass parameters. So you can pass as many as you want, just pretty normal, really. Pretty much the same as you'd pass a parameter to a normal function. Okay, and the capture list. All right, so moving on to the capture list. by default, you can't use any of the local variables in the surrounding code in your Lambda body. They're out of scope. So let's have a look at what that means. If we've got a local variable here in main, say I, and it's set to 10, you can't use them in your Lambda. Yeah, look at that. So it's underlined. That I just there is out of scope. Even though this Lambda is defined in the middle of the main functions body, that I variable is local to main. It's out of scope in the Lambda. So what you've got to do is capture it in the capture list. Yeah, so just pop it there inside those square brackets into the capture list, and you should be right as rain. Now we'll get 190 plus 10 plus 10, which should give us 210, all things going to plan. Okay, 210. So that's how you capture one variable. If you've got a couple of variables to capture, say G as well, and we'll set that to, well, 11 maybe, doesn't really matter. You can capture your G as well, just like that. So now we'll get 190 plus 10 plus 10 plus 11. Yeah, simple as that, really. Capture multiple variables by separating them in your capture list with commas. Okay, so the next thing to mention is that they're being passed by value. So it's something like this. It's something like int I equals main.I. Yeah, whatever the local variable for main is, make a copy of that and pass it to the body of my Lambda. This is not always the case, but this is what happens by default, which means that we can't change I. I is read-only from inside the body of our Lambda. Look at that, it gets underlined. Expression must be a modifiable L value. So I and G are read-only because we're passing by value to the body of our Lambda. Hope that makes a bit of sense. If you want to pass by reference, then you've got to put an ampersand beside them, just like that. Yeah. So if you want to pass to the Lambda's body, you want to capture this I and this G variable, but you also want to maybe change them inside the body of the Lambda, you've got to pass them by reference. So now we're free to change them if we want. Something like that. And we could see out the, what is it, I and G down here, just to make sure that they are actually changing. So what we should get now is, well, some sum first of all, because we're calling the Lambda down here, and then we should get the changed values of I and G, so 89 and 10 printed on the next line. Let's have a look. Have a look how we go. Yeah, there you go. So 299, 89 and 10. Good stuff. So that's how you capture a couple of local variables by reference. All right, but there's another two little things that you might want to do, some little tricks, little Lambda tricks, little Lambda techniques. Syntactic sugar. If you put equals in your capture list for your Lambda function, then what it means is for the compiler to look at all of the variables that you've used inside the body of your Lambda and add them automatically to the capture list. So equals just means, you know, I've used the I and the G down here. The compiler will see that and it will say, well, what he means is I and G in the capture list. Yeah. So any variables that you use here at all, you know, you could use many variables as you want, and they'd be added automatically to the capture list if you put equals there. Okay, so that's really, really handy. If we just hit run, we should see whatever we saw before, the I and the G being captured. Yeah, they were well captured, 221. Equals does mean capture by value, so once again, we can't change the I variable or the G variable if we use equals. The symbol to capture by reference any variable is the ampersand by itself. Now, so if you put an ampersand with no variable in your Lambda's capture list, it means anything I've used in the function in the body of the Lambda, capture it by reference. Yeah, so that's handy as well. And you can mix and match to a degree. So if you've got an ampersand, then it means capture anything I've used in the body of my Lambda by reference, but then you can specifically say I by itself. And this means capture the I by value, but everything else capture it by reference because of the ampersand. So you can see once again down here that if I'm capturing the I variable by value, I can't actually change it inside the body of the Lambda. It's read only. The other alternative would be to capture everything by value except for I, which I want to capture by reference. Yeah, that would be how you specify that. Just put an ampersand beside your I and an equal symbol. Once again, down here, because of the equal symbol, the G is being passed by a value, and we can't change it inside our lambda. Yeah, anyway, that's a bit about capturing, bit about the capture list. I've got a few examples here. They're not particularly good examples, but there's one about computing the circumference of a circle. Slide here about equals and ampersand. Yeah, we went through that. We went through all of this before. There's another example here about finding the largest of 3 integers. I mean, you would never do this in reality. Don't know why I bothered putting it up on the slide, frankly. Okay, here's something new. So this is using STD for each and a lambda. This is really probably the first example in all of my examples so far of a lambda being used in a way that's sort of useful, or something like how you might use it in real life as opposed to fictional life. Okay, so I've got a little vector here called ARR. It's got 5 integers in it, 1, 2, 3, 4, 5. This is a new syntax as well, I think. Setting up the items in a vector like this, but we're not going through that now, so let's just move along. Then I've also got a local variable called total, which is a double for absolutely no reason. Might as well make it an int. No, keep it as a double. Okay, but the next thing that we do is call STD for each. So in order to call for each, you need the algorithm header just here. Yeah, but for each takes 3 parameters. The first and second are iterators, the first and last elements that you want to actually iterate through. So the begin here of ARR is this 1 just here, and the end here of ARR is this 5th element just here. And what for each is going to do is it's just going to run through every item in the vector, between those 2 elements inclusively. So the 1, the 2, the 3, the 4, the 5. And it's going to call the function that's specified as the 3rd parameter. Yeah, so we could up here have had a separate function, something like int add to total, or like that, and int x and int total so far, like that. And then we could have said, total so far plus equals this, that, and the other, and return whatever you feel like. But a lambda is more convenient. So instead of defining some other function, figuring out where to put it, we might put it in a separate header over here and defining the function like I just did. What we can do is just define the function in place, right where we need it, as an anonymous lambda. Just stick that in the position of this 3rd parameter just here. So the capture list for this little lambda down here is ampersand, which means anything that I've used inside the body of my lambda, which is right here, I want to capture as a reference. So this total variable here, which is local to main, is the only local variable that I've used. So yeah, that's going to be captured by reference for this particular lambda. And then the for each is going to pass each element, 1, 2, 3, 4, 5, through this x integer just here. Yeah, so long story short, this little lambda is just going to add all of the elements together. We should get 15. There you go, 15. Okay, but the cool thing about this is just the convenience. I haven't had to define some global list of weird little functions that add things together, in a separate header. I haven't had to define a function up here that computes some sum or anything like that. I've just placed the sum as an anonymous function. Using a lambda in the middle of my for each call. All right, that's an example of for each. Lambdas and sorting. Okay, here's another example, I think pretty useful example. This is an example of how you might use lambdas in a call to STD Sort. Okay, so this I think includes its own everything, this particular code sample. We've got a basic point struct just here with double x and y. Just set those to random values in the constructor. And the only other method I've put here for the point struct is a print method, which just uses cout to print the coordinates, x and y. All right, if we move down to the main, we'll see our call to STD Sort. All right, so we set up a vector of 100 random points, just using a bit of push back action. And then I print out the first 10 of those just to make sure that they're unsorted. And the next thing is we call STD Sort. So that takes 3 parameters. What we want is a beginning iterator, an ending iterator, much like the for each loop just a minute ago. And the third parameter that it takes is a comparison. So the comparison returns bool. It returns true if A is less than B, otherwise it returns false. So once again, if we wanted to, we could have come up here to our point structure and we could have defined, with operator, this thing and point A and point B, and if point B is bigger than A, then do this and otherwise return that. We could have defined a less than operator up here, or we could have defined some other function somewhere else in some other header that compares 2 points together right here or something like that. But what's really cool is that with modern C++, we can just use a lambda and define this little comparison function without a name right in the middle of the sort call. Yeah, so that's what I've done here. Really what lambdas are for. They're just for convenience. Alrighty, so the capsule list is nothing. We don't want to capture anything from main for this particular lambda. Sort is going to pass us points or elements from this point vector, 2 at a time, so A and B, and it's going to perform the comparison that follows the body of the lambda down here between the two, and it's going to use this lambda here to sort them into sorted order using like quick sort or a hybrid of a bunch of different sorts. We don't really care how it sorts. The 2 points I'm passing here by reference with ampersands, that's just for speed purposes, and then because it's dangerous to pass by reference, just in case I forget down here and try and change a.x to that, which I wouldn't anyway, but you put const there as well. Alright, so the compiler's actually smart enough to know that this particular lambda here returns bool, so this is optional. Yeah, we could get rid of that if we want. And basically all we're doing here is sorting based on how close the points are to the origin. Yeah, that's all this little expression here does. So if we hit run, what we should see is first of all some unsorted points, and then we have to do a breakpoint somewhere, boy. Yeah, there we go, some unsorted points, and then we sort them. Alright, so unsorted negative 4900 and 3400 are obviously very far from the origin. And once they're sorted, we see that negative 173 and 436 was the closest point to the origin. 0, 0. Okay, yes, but the main purpose of this demonstration is just to show that it's more convenient, sometimes, arguably, to just define this little nameless lambda function in the middle of your sort call, rather than figure out where to put this operator that compares points. Or describe some other function and call that in your sort call. So this is really what lambdas are for, just convenience. Okay, so that's a little bit about sorting, and I think we've got one more example. All right, this is the final example. So this is lambdas and STD function. This is a weird example. This is a weird example. Very, very cool though, really, and it shows really one of the most powerful uses of lambdas. Mind you, it doesn't show it in a very useful way. Okay, so we've got a function up the top, perform operation, that takes one of these STD functions. So this is a basic kind of generic function pointer type. STD function is super, super useful for passing functions around as parameters. It's not the topic of today, so we'll just move on. Alright, so we pass one of these STD functions as f, and then we call it. Fair enough. And down here in main, we've got this local variable called 100. Then we define a lambda called func. Let's just capital, there you go. All right. It takes an ampersand in its capture list, so anything I've used in the body, which happens only to be the x variable, I want to capture by reference. Yeah, in my lambda. Then we call this perform operation, this function up here, and we pass it the lambda as our STD function. And what's going to happen is pretty obvious. The x is going to be incremented to 101, so we print that to screen. And if we just put a sort of breakpoint here and we run it, we should see 101 printed to the screen. Yeah, there you go. But what's interesting about this is that this function call up here, f, is what actually incremented x. And if you think about it, x should be out of scope. Yeah, x should be out of scope, but we've used a lambda and we've captured x. so that, or we've captured X by reference so that wherever this lambda is called, X is just magically in scope. So we can increment X from up here in perform operation, even though in theory, you know, it looks like it's out of scope. Very, very cool. Very cool. There's more useful uses of that too. So I don't know, if there's interest, I'd like to make another video on lambdas. They're really interesting, really interesting. Colorful little beasts. Alrighty, so in summary, lambdas don't actually offer us any new abilities. You could do anything that lambdas do, you know, in C, even in assembly if you want. You don't have to use any of these modern programming tricks, but they do offer us convenience because you can just define these little nameless functions where you need them, rather than having to think of a special name for the function and write the prototype for the function and put it in some header somewhere. Yeah, it's all about convenience. They're really, really cool. Are they useful in multi-threading as well, which we didn't look at all today, but you know, maybe we can go through another time. Anyway, thank you very much for watching, and you're all a bunch of legends, and have a good day. All right, see ya.